So number 8 then, from the 2022 mechanics paper, 5 marks here for, now it's a rotating system. A small object of mass m is placed on a rough horizontal disc at a certain distance from the centre, so there's that little mass there. The disc is rotating at 1.5 revolutions per second. And this is just on the point of slipping. If that's the case, calculate the coefficient of friction. For 5 marks here. Well, the first thing is, whenever you've got a rotating system, don't think of centripetal and centrifugal force because you're just getting confused. Think of F equals ma. In order for that point to be forced to travel in a circle, it would have to be accelerating inwards. And if it's accelerating, there has to be a force that produces that. So that's what you have to find. That's what you're combining. It's just that F equals ma. So that's the essence of this question. F equals ma, where a is the acceleration towards the centre necessary to keep it turning round and staying there. Now it's just a case of putting all the different parts in. What could possibly supply that force because it's just sitting there? Well, the only force that you've got is the contact with the disc. So that force must be the force of friction. So that force must be mu times the normal reaction, N or R, whichever you like, because what you've got is, if that's sitting here, then since it's sitting there, obviously that disc is supporting it and providing a reaction, which will equal mg. So now you've got this, that force is going to be mu mg. Now, I don't know if there's 1 or 2 marks for that. Now what about the acceleration though? Well, the acceleration towards the centre will either be v squared upon r or omega squared r, depending what you know. Well, since it's the rotating, I don't know its actual speed, it's the rotation that I know, I'll be using this one. That means you'll need to know omega. Well, omega means the rotational velocity in radians per second, not complete turns per second. So if it's 1.5 complete turns, it's 1.5 lots of 2 pi. So it'll be 2 pi times 1.5 for the angular velocity. So that's 3 pi radians. We're getting that 3 pi is worth a mark. Then you just put it all together using this, using F equals ma. Using F equals ma, you've got the force. Well, the only force there is the frictional force, mu mg. Mass times acceleration. Well, the mass is m, and the acceleration is going to be, I'll just put it down, omega squared r. Now, that's the critical line. The force that produces the acceleration is the force due to friction. But there was actually 4 marks up to here, including that one. So I suppose the other 2 must have been this. Expression for the force of friction, expression for the acceleration. Now you just put together, well, the m's will cancel out. So to leave mu with the m's cancelled out, I'm just left with omega squared r upon g. 3 pi squared times, and I've forgotten what that was, at a distance of 0.07. 0.07, I should have had that in there, 0.07 metres. Over 9.8. And pressing the buttons gives you mu equals 0.63447 and so on. And then taking it to the 3 decimal places, 0.634 for 1 mark. Although I'm not awfully sure about that because you've only got 2 significant figures there, for instance.